Right, so this section of the chemical analysis topic is looking at positive metal ions. If you are doing triple science, you need to go through this, but if you are doing combined, this is not required, so you won't need to learn this. Now, the first part of the section is looking at how you carry out a flame test. So it's relatively straightforward. You need a nichrome wire loop. Now, what you need to do is you need to dip this into hydrochloric acid, into concentrated hydrochloric acid, and put it under the flame. So you then heat it up. Now what that does is it gets rid of any impurities that you might have on that loop from a previous experiment. And once you've done that, that basically cleans it out, and then you dip this into more HCl. Now, you need to do that before you put the loop into the compound that you are testing. So you dip the loop into the compound. Now you then take the loop and you put it under the flame. So put it under roaring flame, and hopefully you will see a color change. Now the color change is obviously relative to the metal ion that you will identify. So the main color changes, you've got crimson. Crimson is caused by lithium ion. Now remember, these are metal ions, so it's not lithium, you've got to say lithium ion. If it's a yellow flame, then it is caused by sodium ion. And if it's lilac, purple, that is caused by potassium ion. So those are your group 1 metals, and then two more that you need to be aware of. If it's an orange, red, that's usually caused by group 2 ion, so calcium ion. And the last one is if it turns green, then that is caused by copper 2 ion. So those are the colours that you need to learn. There's no way around it, and how you carry out a flame test is also required. Right, the second part of looking at positive ions is looking at some precipitation reactions. Right, so if you have compound X and you wanted to work out what positive metal ion is in this compound X, the first thing you need to do is you need to add some sodium hydroxide to it. Now what the sodium hydroxide reaction will do is it will produce a precipitation reaction. There's two possibilities. You can have a precipitation reaction with a coloured precipitate, which I'm going to call PPT, or you can have a white precipitate. So those are your two possible options. Now if it's a coloured precipitate, it can be one of three metals. So it could be copper ion, or Fe2 plus ion, or Fe3 plus ion. So it will have to be one of those three. And if it's a white precipitate, it will have to be aluminium ion, or magnesium ion, or a calcium ion. So those are your other possibilities. Now if it's a coloured precipitate, there's three options really. Now if it's a blue precipitate, then what we know from earlier chapters is a blue precipitate, or blue compounds generally associated with copper. So that's copper sulfate crystals, for example. So that's Cu2 plus ion is what causes that to happen. If you get a light green precipitate, then that is caused by Fe2 plus ion. And if if you get a red brown sort of looking like rust precipitate, what we do know is rust is associated with Fe3 plus ion. Okay, so those are your three colors. Now if you get a white precipitate, what you need to do is you need to add more NaOH, so excess NaOH, so sodium hydroxide, and then two things can happen from that. You can get the precipitate dissolving, or the precipitate remains insoluble. Okay, so it doesn't dissolve. Now if it dissolves, then it could only be one ion that happens to, so that's Al3 plus ion. If it is insoluble, then it would be happening to a possibility of two ions, the remaining two, Mg2 plus or Ca2 plus. So it's one of those. Now you can then do a flame test between this to work out what is what, and that will give you a color change, and that should be enough to identify the unknown metal ion.